Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at Summer 19, our IGCSE paper 21, Summer 2019. And I wrote down here because this is 2019, we're already moving into the new 2020 syllabus cycle. And in the new syllabus, you actually have derivatives, conditional probability, and sketching of the basic trigonometric functions. So this 2019 paper will not have those three topics, but there's still plenty of other things that we can look at. Now, remember, the important thing is as you go through these papers, it's not just that you can get the answer that's in the mark scheme. You need to learn how to think, how to set up the problem, how to work through the problem, make sure that you understand what's going on. That's why I want to go over it with you and not just give you the answers, but to work through with you to help you learn how to think through these question types that you will see here. So question number 1 says, work out $1.20 as a percentage of $16. Now, percentage here, we'll make it a percent sign, and of usually means multiplication. So percent multiplied by 16. And so this as is basically functioning as an equal sign. So the $1.20 as or equals some percent, which we're looking for, of or times $16. So to solve for this percent sign, we're going to divide by 16. And then when you do that on your calculator, you get 0.075. And because we want it as a percent, not as a decimal, we need to move it over twice to the right, which gives us 7.5%. And then you just write that in the answer there. Number 2 is a factorization. Remember, factorizing is looking for what's common to all the terms. So when you look at this first term, you have a 5y, and the second term you have a negative 6py. So there's a y that's common to both terms. So we factor it out. Factoring is dividing. So 5y divided by y just leaves you with 5, and 6py divided by y leaves you with a negative 6p. So that was pretty easy. This is just monomial factoring here. Number 3 is a calculation. You just do it on your calculator. Make sure that you get the right value here, the 4.01 or the 4.0078. And what's important is that you can enter it into your calculator and get your calculator to follow the correct order of operations. So if you get it right, then you probably understand your calculator. If you don't, then you need to have someone show you how to do that correctly. Number 4, I don't remember why I have it circled, but anyway, an equilateral triangle has sides of length 15. So equilateral means they're all the same, 15, 15, 15. Correct to the nearest centimeter. Calculate the upper bound of the perimeter of this triangle. So in upper and lower bounds, there are 2 layers, usually 2 layers. The first layer deals with the number itself, and then the second layer deals with the formula. So in the first layer, because it's correct to the nearest centimeter, then we're going to take a ½ centimeter above and below. And so anything from 14.5 will round up to 15, and then all the way up to, but not including, the 15.5 will round down to 15. We still put 0.5. You can't put 0.4 because it could be 0.499999. So we just put the 5 and understand it's actually not included, but we still use the 5. So the upper bound is the 15.5, the lower bound would be the 14.5, and this is the first layer, is with the specific numbers that are being used, the specific measurements. Now the second layer has to deal with the formula. So the formula here is perimeter of a triangle. So your formula is going to be perimeter equals side plus side plus side, which is 3 times the side. And since it wants the upper bound, we're going to take the higher value and plug it into our side. So the perimeter, the upper bound perimeter will be 3 times 15.5, which gives us 46.5. Meaning here, if you looked at this 15, 15, 15, your perimeter would be 45, 3 times 15. But because measurements are not exact, there is that little bit of range in there. So the highest possible value that you could get would be up to, but actually not including the 46.5. Okay, so that's how that works. Then number 5, we have the volume of a cuboid is 180 centimeters cubed. The base is square with length of 6. So here, sorry, my three-dimensional drawing's not really that great. And so here's a cuboid, square base, so 6 all the way around, and then an unknown height that we're going to find. Well, your volume is length times width times height. That needs to equal 180. So 6 times 6 is 36. Divide by that, the height is 5. So this shouldn't be too difficult here. Moving on to number 6, says simplify. Says t to the 21 divided by t to the 7. This is just basic exponential rules. When you divide, so here I put it into a division bar instead of using the divide sign. And with the division bar, t21 over t to the 7. And when you divide like bases, you subtract the exponents. So remember, division is a fast way of subtraction. So 21 minus 7 gives you t to the 14. Then down here we have another exponential rule. We have an exponent raised to an exponent. And in that case, you multiply because exponents are a fast way of multiplication. So 5 times 5 is equal to u to the 25. So here's just a question that deals with basic exponential rules. Now we get down to a trigonometric question here with SOHCAHTOA. SOHCAHTOA is sine opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. When you're dealing with right triangles, you can use SOHCAHTOA. First thing you need to establish is the angle, that is your point of orientation, is which angle are you coming from? So we're coming from this angle over here, the 35 degrees. So from this angle, you can then label your sides. So this over here is the opposite. This one is the hypotenuse because it's across from the 90. And this one down here is the adjacent. So again, 35 degrees. So make sure your calculator's in degree mode. And so the two sides that we have with respect to our angle here is the opposite and the hypotenuse. Here you see O and H. So that means we're going to use the trigonometric sine. So sine of the angle, sine of 35 equals the opposite, which is X, over the hypotenuse, which is 12. So to solve for X, we just multiply 12 times sine of 35. Again, make sure your calculator is in degree mode before you do any trigonometric calculation. And when you do that, should come out to 6.88 to 3 significant figures, which most of your answers in Cambridge need to be 3 significant figures unless otherwise designated. Moving on to number 8, here we have geometric circle type question. And what we need to find is find the obtuse angle AOC. So the acute angle is in here. Here's AOC. The acute angle would be in here. The obtuse angle is this one out here. And it wants us to find the obtuse angle AOC. No, I'm sorry. it wants this one in here. It wants AOC. It calls it obtuse because it's greater than 90. It's not this one. This one's part of your major arc. This is your minor one. It wants this one right here, the inner one, AOC. And to get that, the only value it gives us is 130. And 130 is what's called an inscribed angle. The vertex is on the circle itself. So that's an inscribed versus up here, AOC is a central angle because it's connected to the origin. So this is a central angle. This is an inscribed angle, angle B here, 130. And so inscribed angles, the central angle, or you could use the arc as well, is twice 2 times the inscribed angle. So 2 times the 130 is 260. You can either put it in here as the central angle, or you can put it out here on the arc. I prefer to use the arc because there's some questions that Cambridge gives you with geometric properties of circles where if you write everything inside the circle, it sometimes gets kind of complicated and tight. So I like to spread it out. I like to use the arcs, and it helps me to see a little bit better. But remember, your arc and the central angle are the same value. So what we want is this AOC in here, and this makes a complete circle. So 360 minus the 260 on this side, which I wrote out here, equals 100 degrees. It is obtuse, and it is the AOC, but it's the AOC in here is 100 degrees. Number 9 is reoccurring decimals. So notice 0.47, there's a dot. That's not a speck of dirt, that's a dot. Cambridge uses a dot. Some systems use a little dash to show what number or numbers repeat. So it's only the 7 that repeats. So I take it here and I write what we have here, the 0.47, and I have put x equals, save a little space, 0.47, and then I go ahead and repeat the 7. It's only the 7 that repeats, not the 4. There's no dot above the 4. Then because only 1 digit repeats, we're going to multiply both sides by 10. If 2 digits repeat, meaning there's a dot above both, then you would multiply by 100. If 3 digits repeat, you multiply by 1,000. So for every digit that repeats, you multiply by a power of 10. So 1 digit repeats, we multiply by 10. So we get 10x equals 4.777. Now remember, these 7s keep going. I didn't write like dot, dot, dot. And now we're going to subtract. So since all of these are 7s from here on out, when we subtract, all those 7s that go out here will cancel. And this one, 7 minus 4 is 3 on this side of the decimal. On this side, you have 4 minus 0 is 4. Over here on this side of the equation, equal sign, we have 10 minus 1x is 9x. And then divide by 9. So we get 4.3 over 9. Don't leave it like that. You're not allowed to have decimals in a fraction. So we need to move that decimal over one place. Whatever you do to the top, you need to do to the bottom. So basically, you're multiplying top and bottom by 10, or just moving that decimal one space to the right, which gives us 43 over 90. 43 over 90. So that's how you do reoccurring decimals. Again, make sure you get your thinking pattern down so that you can do these on each test set. Number 10 gives us a function notation here. F of x equals 2x plus 3. This is our function. Now it wants us to find our function evaluated for 1 minus x. So this 1 minus x is replacing the x. So that means in the equation, we need to also replace the x with the 1 minus x and then evaluate it. Remember, on a function notation, the left-hand side is the notation itself. It tells you what to do. On the right-hand side is where you carry out the math. So there's no math on the left. It's only instructions telling you what to do. So we're replacing the x with a 1 minus x. So here we replace the x with a 1 minus x, distribute the 2, and then simplify. So 2 plus 3 is 5, minus 2x. That is our answer right there, 5 minus 2x. Moving on to number 11, we get to a probability question. We have 5 cards numbered 1 to 5. 2 of the cards are taken without replacement, so we don't put it back. Find the probability that both cards show an even number. So our category here is even. So if there's evens, the other category then would be odds. What we want to do is we want to come up with a tree diagram that would represent the total possibilities. So if they're looking for even, then odd would be the other ones. So we look and we see there's a 2 and a 4. So 2 out of the 5 cards are even, and a 1, 3, and 5. 3 out of the 5 cards are odd. Remember, in tree diagrams, each branch set needs to add up to 1. Total probability has to be 100%, so it has to add up to 1, which it does. Then that would represent the first card taken, and that card is not put back. So then we're going to draw again, which is going to be represented by the second branch set. And again, you could draw an even or an odd. And this time, because we've already drawn an even, now there's only 1 even left. And because we didn't put the card back, there's only 4 total cards. Now I drew the tree diagram, but I didn't finish putting the numbers in because it wants just both even. So we don't need odd odd or odd even or even odd. We just need even even. You could have done it without the tree diagram. I'm just using the tree diagram to explain it for you. You could have done it mentally, 2 out of 5, and then 1 out of 4 equals 2 out of 20. Notice in the mark scheme says or equivalent, meaning you don't have to reduce it. You could put 1/10 is okay. You can leave it as 2 over 20. Usually with probability, they're more flexible. They don't expect you to reduce it, but you can if you want to. The OE means or equivalent. So they'll take whatever answer you have as long as it's correct. Could have even put 0.1 if you wanted, if you put it as a decimal. Here we're given a list of numbers, and we're simply asked to find these particular things here. So from the list, write down a multiple of 7. Well, the only multiple of 7 here that I see is 28. That's 4 times 7. So 28 is a multiple of 7. Then a cube number, meaning the number you get after you cube something. So that'd be 27 is 3 cubed. So this is seeing if you can recognize these number relationships here. And then a prime number. There's 2 prime numbers. Remember, a prime number is a number that only 1 and itself can divide into. So notice 27 is divisible by 3, 28, 30, and 32 are all divisible by 2, and 33 is divisible by 3. So 29 and 31 are the only prime numbers here. So I just wrote 29. You only need to write one of them because it says a prime number. Number 13, this gets to what's called completing the square. We're taking it from a quadratic and we're writing it into this form here. It's called completing the square. I do have a video on this. Actually, I have 2 videos in the AS level in the Pure Maths 1 book that go into this quite in depth on how to do the completing the square as well as the concept of completing the square. But if you don't want to take time to look through 2 videos, you can just follow this. Basically, what completing the square is, there's different functions for it. So the reason why you want to do that varies by context, but basically it means you can't factor this. So assuming you can't factor this, normally when we factor, we break apart this third term here, the A, B, C, the C term here. So because it can't factor, In other words, there's no factors of 9 that give us 4. So this doesn't work. So we're going to move that -9 over because it doesn't work as far as factoring goes. And then what we want to do is we want to find a number that does work. So to find the number that does work, there's a little formula. I didn't write it here. I probably should have. And it's b being the second term, the coefficient here, b divided by 2 squared. That's the formula to find the magic number. That's what I call it, the magic number for completing the square. So here's the b, 4 divided by 2, 4 divided by 2 is 2, and then squared gives us a 4. So I kind of did this in my head, but the formula for complete the square is b divided by 2, and then that value squared. So that gives us a 4. That's our magic number. Now we just introduced a 4. So to maintain the balance of our expression here, we need to also subtract 4. Now you say, why would you add 4 and subtract 4? Doesn't that just make 0? Well, yes, but we want to separate it into parts so that this part over here can factor, and notice it factors into a perfect square. That's why it's called complete the square. And then this part over here is just the kind of the leftover, although it is a valuable piece of information when you're dealing with quadratic graphs. So here we have x plus 2 squared is what this factors to. It's a perfect square. Factors of 4 that add up to 4, 2 and 2. So you get x plus 2 squared, and then these two here, -9 minus 4, make a -13. So if you look at the pattern up here, here's the a is the +2, and the b is a -13. You should be able to do this. Make sure you learn how to do completing the square, because after IGCSE, when you get up into the AS level, you're going to be doing this quite a bit. Number 14, without using a calculator, work out 5/6 plus 2/3. So here I wrote it down here. Whenever you're adding or subtracting fractions, you want a common denominator. So we want 6, multiply top and bottom by 2, gives us 4/6. Then we can add, gives us 9/6. Notice it says write it as a mixed number in simplest form. So 9/6 can reduce to 3/2, and then as a mixed number, 2 goes into 3 one time with 1 left over, so 1 and 1/2 is the mixed number. Actually, there's calculators that can also change it from, if you use the ABC key, there's an ABC key on your calculator that can change improper fractions into mixed numbers for you. Number 15, expand and simplify. Expand means to multiply. So when we look here, we have this multiplication of binomials. So we use the smiley face method, or if you call it the FOIL method, I like calling it the smiley face method. X times x is x squared. 1x and 2x add up to 3x here. And then 1 times 2 is 2. And then here, this is plus 2x times x is 2x squared. 2x times -3 is a -6x. So when we combine this x squared, now we're doing like terms, means same variable and same exponent. So x squared plus 2x squared is 3x squared. Here we have an x plus 2x is 3x minus 6x is a -3x, and the 2 is all by itself. So there is our polynomial expanded and simplified. Okay, number 16 here. Number 16 is an inverse proportion. So y is inversely proportional to the square root of x plus 1. Now, directly proportional means your constant multiplies. Inversely proportional means your proportionality constant has a division here. So y is, that's our equal sign. Don't forget the proportionality constant, that's the k. You have to put that in yourself. Inversely means divide, Pay close attention to the wording here. It's square root, not the square. Square is exponent, square root is the radical. So the square root of x plus 1. A lot of students don't read that carefully and they get mixed up between square and square root. So that is the square root of x plus 1. So here is our pattern that we're looking at. So we're going to stick in the first set of numbers, 8 and 2. So plug in 8 and 2 for x and y. First thing we're going to solve for is the k. We need to know what that proportionality constant is for this particular problem. So 8 plus 1 is 9. Square root of 9 is 3. And multiply it to the other side, so our k is 6. Now that we know our proportionality constant, we can plug that in for k, go back to our original formula here, plugging in the k. Now we can go to the second set. X is 99. We need to find the y. So we plug in the 99 for the x. 99 plus 1 is 100. Square root of 100 is 10. And 6 divided by 10 is 6/10, says or equivalent, meaning you could put 3/5, you could put 0.6, as long as it's mathematically the same thing. But again, make sure that you understand your thinking process here. Start by, is it either divide inversely proportional or multiply directly proportional? Read it carefully so that you set it up right. Use the first set of numbers to solve for the k. Once you get the k, then use the second set of numbers to solve for the missing variable. Usually have one of these on every test set. Number 17 is factoring. So hopefully, again, I have a factoring video in the Pure Maths 1 for AS level. If you struggle with factoring, you can go through that video. It goes through a lot of different types of factoring that you'll need for Cambridge. This one you should recognize as a difference of squares. So a difference of squares means you have one of each sign, positive and negative, and with just the base here. So make sure it's in its squared form. So you just have p plus q, p minus q. This is about as basic as it gets for difference of squares. Now down here, we actually have to solve something using simultaneous equations. Here it gives us a quadratic equation. Over here, a linear equation. And we need to find the value of p plus q. So we're going to have to solve simultaneous equations. And you can't use elimination because our powers are different. So we're going to have to use substitution. So I solve for p, add that q to the other side. So p equals 2 plus q. Then I plug this into the first one, and you see it right here. So 2 plus q squared minus q squared equals 7. Multiply that out. Remember, this is squares do not distribute to add and subtract. So you need to multiply this out, smiley face method. 2 plus q times 2 plus q gives you 4 plus 4q plus q squared minus q squared equals 7. The q squareds cancel, giving you 4q equals 3 because you're going to subtract the 4 from the other side. So 4q equals 3. Q equals 3/4. Now plug the 3/4 in back up here into this equation up here. 2 plus 3/4. So you need a common denominator. So 2 is 8/4. 8/4 and 3/4 is 11/4. And we want to add those two together. Don't forget to look at what you're supposed to do with your values. And so we're going to take 11/4 plus the 3/4 is 14/4, which reduces to 7/2. Here we go back to our exponent rules again. We have 81y to the 16th raised to the 3/4 power. Again, we have exponent raised to the exponent. So our exponent distributes to multiply. The 81 is multiplying by the y 16th. Exponents distribute to multiply and divide. They do not distribute to add and subtract, like we talked about up here. They do distribute to multiply. So the 3/4 goes to the 81. The 3/4 also goes to the y to the 16th. On the 81, you basically can do it in your calculator, or you can do it mentally. The bottom part of the fraction is your root. So the fourth root of 81 is 3. The top number is your exponent. 3 cubed then is your 27, or you just do it in your calculator. For the y to the 16th, an exponent raised to an exponent, you multiply. So 16 times 3/4 is 12. So you get y to the 12th. 27 y to the 12th is your answer. You get 1 point for basically each part. Then we have, actually, this is an exponential because the variable is up in the exponent place. And what they want you to do is get like base. So the base here is 2. So we want to convert our 4 into base 2. And so the 4 can be written as 2 squared. And again, exponent raised to an exponent, you multiply. So we get 2 cubed equals 2 to the 2p. Now, I don't really like this about Cambridge. They basically just have you, once you have the like base, they just have you poof the base almost like it's a magic act. It disappears and you get 3 equals 2p. I don't like that because math is not magical. Actually, you're supposed to take a logarithm of both sides to get those 2 to cancel. But since you haven't been taught logarithms yet, they just have you poof the base. As long as your base is the same, you poof the base, it disappears. Technically, you're using logarithms. So I don't really like that part because you don't really know what you're doing or what operation that you're doing to it to make those 2's disappear. So you are actually using a logarithm, and the 2's will cancel, and you get 3 equals 2p. Solve for p equals 3/2. Then we move down here to the scale things, and these can be a little tricky. So what you need to remember is not only your ratio, but you also need to pay attention to what dimension you're in. First dimension is linear, second dimension is quadratic or area. So first dimension is linear or length. Second dimension is quadratic or area. Third dimension, cubic, is volume, okay? So it says the model of a car has a scale. Scales are usually given to you in a linear or one-dimensional scale. So here's your ratio. The model for every 1 unit, and at this point, it doesn't really say, it does down here, but for every 1 unit of model, there are 20 units in the real thing. So your model car is smaller than the real car, and its scale is 1 to 20. So this is linear or first dimension. Now it says the volume of the actual car or the real car is 12 meters cubed. So what it wants you to do is find the volume of the model, and they want you to give it in cubic centimeters. So not only do we have the ratio, we also need to pay attention to the dimension, and we also need to do the conversion because it changed from cubic meters to cubic centimeters. Okay, so first let's deal with the ratio. Our ratio that it starts off with is linear, our first dimension, and it is 1 to 20, the model to the actual. What we want to do is we want to convert this ratio from a one-dimensional concept into a three-dimensional, to the volume. So we're going to cube this ratio, and so we get 1 cubed and 20 cubed, and it becomes 1 to 8,000. So the one dimension of 1 to 20 in the 3 dimension becomes 1 to 8,000. Now this is in cubic meters. So, but before we do that, let's use we need to solve for our x here. We need to solve for our model. We have the actual car is 12, and we don't know the model. the volume of the model. We know the ratio of the volume, but we don't know what the volume of the model itself is. So it's an x to 12 ratio because it already gives 12 for the actual. So we can cross multiply and get 12 equals 8,000x. So x is 12 over 8,000, which reduces to 3 over 2,000. Now, so for every 2,000 cubic meters, the model is 3 cubic meters. But what we need to do is we need to now convert units because we're going from cubic meters to cubic centimeters. So down here is, here's our, we want to get rid of meters, cubic meters. So we're going to put it on the bottom. And what we want to go to is the cubic centimeters. We're going to put that on top. Now we know the linear ratio from centimeters to meter. 100 centimeters is 1 meter. So this is the linear bridge, 100 centimeters to 1 meter. But we want a cubic of that. So we need to cube top and bottom. And so that gives us actually 1 million to 1 and our 3 to 2,000. We multiply that. And when you do that on your calculator, basically your model comes out to 1,500 cubic centimeters. So this is a little bit tricky problem. Again, you have your ratio, which in this case has been given to us in a one-dimensional way. And then it goes to volume, which is 3 dimensionals. That's why we have to cube it. Then you use your ratio to solve for the missing part, which was the volume of the model. We had the volume of the actual. Then once you had that, then you had to convert your units from cubic meters to cubic centimeters. Again, just pay attention to your units. This was cubic meters, so you want meters on the bottom, centimeters on top, so that you end up with cubic centimeters. Number 20, write as a single fraction in its simplest form. Again, this is just adding and subtracting fractions, so you need a common denominator. Well, we've got two very different denominators here. So over here on the left, the 1 over x plus 2 needs multiplied by the 3x minus 1. Okay. And the one on the right has the 3x minus 1. It needs multiplied top and bottom by the x plus 2. So this fraction on the left needs the 3x minus 1. This fraction on the right needs the x plus 2. You multiply it top and bottom. So here we get 3x minus 1. And notice our common denominator now is both the x plus 2 times the 3x minus 1. You don't have to multiply them out. Just leave them as separate factors. But now you see that both denominators have that both factors in it. So on the top, don't forget this negative distributes with the 2. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. So be very careful of that sign. It has to distribute through. Then we just simplify the like terms. 3x minus 2x is x. Negative 1 minus 4 is negative 5. You don't have to multiply out the denominator. You just leave it like that. So we've made it one fraction in simplest form, has common denominator, and that's how you do that. Moving on to this, here we have this geometric figure of this pyramid, and it tells you about it here. It says M is the midpoint basically there, has a height of 10, square base with 8 around the sides, and it says calculate the angle between VA, that's this outer edge here, and the base. So the base would be along here. So notice it's this diagonal outside edge and then the diagonal through the base. So this is the angle that we're looking for. So what we're going to start with is the base. Since it's a square base, then that means we can use the Pythagorean theorem to find this hypotenuse. So 8, 8, hopefully you know the pattern. 1, 1, and root 2. So this is 8, 8, and 8 root 2. But of course, this m is right in the middle. So if you divide 8 root 2 divided by 2, you get 4 root 2 on both sides. What we're interested in is this piece right here, the 10 height, the 4 root 2 on the bottom of this triangle, and then the hypotenuse. So I drew it down here. Here's the AV, here's the 10 height, here's the M, this would be the M at the bottom, and then 4 root 2 along the base. We're trying to find this angle. Now that we have a right triangle, you can see all the little right angles there. I didn't draw in the right angle here, but this is a right triangle. Means we can use SOHCAHTOA. Don't forget to put your calculator in degree mode. And since our angle of orientation is over here, the 10 is the opposite, the 4 root 2 is the adjacent. So we want to use tangent because it is opposite over adjacent. Tan theta equals 10 over 4 root 2. This reduces to 5 over 2 root 2. You don't really have to do this. I'm not sure why I did it. You can just plug this into your calculator. To solve for the theta, you have to inverse tangent. The inverse tangent on this side cancels out the tangent, leaving the theta. Inverse tangent on the right side of, and you can just put in the 10 over 4 root 2. You don't have to simplify it. And then on your calculator, you get 60.5 degrees. Now, with angle measurements, you always go to 1 decimal for Cambridge, 1 decimal place for degree measurements. So 60.5 is your answer. Moving on, we get to a sequence here, gives us 4 terms of a sequence. And you can see what you're looking for basically is a pattern. So it says write down the next term. So from 5 to 3 is a gain of +3. Or sorry, from 5 to 8 is a gain of +3. 8 to 11 is also +3. 11 to 14 is also +3. So the next number is going to be 14 plus 3, which is 17. Then find an expression in terms of n for the nth term. So your formula to find the nth term is A1 being the first term, which is 5, plus n minus 1, n being the term that you're on, minus 1, times the difference, and the difference is a +3. So if you take your second term minus the first term, 8 minus 5 is +3. That's your difference. Distribute that through, 3n minus 3. Simplify it, 5 minus 3 is 2. I put the 3n in the front. So an expression is 3n plus 2. If you want, you can double check. Notice 14 is the first, second, third, fourth term. So if you put 4 here, 3 times 4 is 12 plus 2 is indeed 14. So this expression will help you find any particular term that you want in that sequence. Now it says these are the first 5 terms of another sequence: 1/2, 3, 4, 7, 6, 13 eighths, and 21 tenths. Find the next term. Again, it's pattern recognition. You might have to look at it a little bit. So if you look at the top 1, 3, 7, 13, 21, here it adds 2, then 4, then 6, then 8. Hopefully you see the pattern. The next one's going to be +10. Along the bottom, it's just +2, +2, +2, +2, +2. So we add 10 to the numerator, we get 31. Add 2 to the denominator, get 12. 31/12 would be the next term. Moving on, we get to matrices. Now notice I put an X through it. This is another thing that I'm not really happy about that Cambridge has done. When they moved to the 2020 syllabus cycle, they eliminated matrices. I'm a little disappointed because when you go to university, if you go into like engineering or any kind of upper level math in university, you might get into vector fields. And a lot of times with vector fields, you use matrices to help you work with vectors. So I'm kind of disappointed that they've removed it from the syllabus because matrices can be used in upper level maths, although sometimes computers do it for you. Still be nice for you to know how to do it. So I crossed it off. So for the 2020 and beyond syllabus cycle, technically you don't have to do this, but if you're interested, this one is find p squared, which means you're doing p times p. So here's p, 3124 times 3124. When you multiply matrices, you do row times column. So 3 times 3 is 9, plus the 1 times the 2 is 2. 9 plus 2 is 11. So notice when you cross the upper row with the first row with the first column, it intersects first row, first column at the 11 spot. Then if we multiply the first row by the next column, you get 3 plus 4, which is 7. So that's when you intersect the first row with the second column. Then when you do the bottom row times first column, you get 2 times 3 is 6, plus 4 times 2 is 8, 6 plus 8 is 14. Again, that's second row, first column. And then when you do second row, second column, 2 times 1 is 2, 4 times 4 is 16. That adds up to 18. So that would be your answer there. And then we have an inverse matrix. So for an inverse matrix, what you need to do is first find the determinant of P. So to find the determinant, you take the cross downward, 3 times 4 is 12, minus the cross upward. So 3 times 4 minus the 2 times 1, down minus up, and 12 minus 2 is 10. And then you do 1 over the determinant. So that goes on the outside. That's one of the points, 1 over 10. And then inside the parenthesis, we rearrange. We switch the 3 and the 4, and we negate the 1 and the 2, or you just change the signs to the opposite. If they happen to be negative, they become positive. So you negate the 1 and the 2, you switch the 3 and the 4. So this then becomes your inverse matrix. Now you say, why would you do that? Well, if you distributed the 110 through this, and you take that matrix and you multiply it by the original P matrix, you get what's called the identity matrix. So in other words, the inverse matrix is the opposite of the regular matrix, and when you multiply them together, they cancel out, giving you the identity matrix, which is 1, 0, 0, 1. You get ones going down this way and zeros this way. So that's in case you're interested. Now, number 24 here, we have a speed time graph. The diagram shows information about the final 70 seconds of a car journey. First of all, find the deceleration of the car between 60 and 70 seconds. Remember that in a speed time graph, that acceleration and deceleration are the slope of the line. Since this slope is going down, that's why it's called deceleration. So slope is your change in y over change in x. The change in the y value is from 20 to 0, so that's a negative 20. And then the change in your x value is from 60 to 70. That's only 10. So don't forget, you don't put 60 or 70. It's from 60 to 70. So it's 10 units. So that gives you a negative 2. And actually, this is a negative 2 acceleration. It wants deceleration. So the deceleration implies the negative. Sometimes it's a little awkward when you're working with this as to whether to include the negative or not. So if you call it acceleration, you need to say that it's accelerating at a negative 2 meters per second squared. But since it's already calling it deceleration, the D part is your negative, so it's decelerating at 2 meters per second squared. So you don't need the negative because it's already called deceleration. Now find the distance traveled by the car during the entire 70 seconds. Remember, distance is the area under the graph. So that's why I have a 1 and 2 here. 1 is for the area of this rectangle and 2 is for the area of the triangle. So for the rectangle, it's just 20 times 60, which is 1,200. Then for the area of the triangle, remember triangle is half base times height. So 1/2, the base is only 10, the height is 20. So 1/2 of 10 times 20 is 5 times 20 is 100. You add those up, you get 1,300 meters is your distance traveled. Moving on, 25. Sorry, this one is a little blurry, but this is using vectors from this diagram. And it tells you about the diagram here. Here's Q, vector P going this way, and here's your diagram. So in the first part, it wants us to go from K to L. K to L, pay attention to your direction. It's going this way from K to L. And so K to L is going to be end minus start. In other words, the L is your end. K to L, you end at L, minus the start is your K. So the L is the end. To get from the origin to L, you go over P and then halfway up, so half Q. So P plus half Q is how you get to L. Okay, that's the end. Then minus, and now we need the start. The start is how you get from the origin to K. So we have Q plus. Now if you followed the what it says in here, there's a ratio of 2 to 1. CK to KB is a ratio of 2 to 1, which means the total is 3. So CK is 2/3 of CB, which is the same as P. So this is 2/3 of P. Q, which was this, plus 2 out of 3 of the P. Now at this point, it's just algebra, distribute the negative Q minus 2/3 P, combine like terms. P minus 2/3 P is a positive 1/3 P, half Q minus Q is a negative half Q, and that's your KL. Now it says find the position vector of M. So position vector means M from the origin. You can draw that in. Don't be afraid to draw lines in your diagram. So the origin to M. So we can either go this way or we can go this way. We need to figure out how to get from O to M, and we can go this way or this way. And when we simplify it, it will give us OM. Now, I want to go this way because we did K to L. In other words, we went this direction. So I want to go this way. So we're going to go OC, CK, and then K to M. So I didn't write it out. Sometimes it's better to go ahead and put these capital letters first. O to C plus C to K plus K to M. So we have Q plus 2/3 P. We already figured that out there. So Q plus 2/3 P. And now M is the midpoint of KL. So we want half of KL, which we've already found. Half of our KL. So 1/3 P minus 1/2 Q. So make sure your KL is correct because this is a linked problem. If your KL is wrong here, well, you're going to get this wrong down here. Now, again, that you've got it set up, the Q plus 2/3 P plus half of your KL. Again, it's now just algebra, distribute your 1/2. So you get 1/6 P minus 1/4 Q. Simplify your like terms. Here's your 2/3 P plus 1/6 P, and gives you 4/6 P plus 1/6 P is 5/6 P, and a Q, which would be 4/4 Q minus 1/4 Q is 3/4 Q. So this is your vector here from the origin to M. So position vector means from the origin. Now number 26, line L passes through the points 0, -3, and 6, 9, and it wants you to find the equation of a line. Remember, equation of a line is y equals mx plus c. You could also use the point slope form if you want to. Generally, I use the slope-intercept form just kind of out of habit, but you can use the point slope form if you're familiar with that. So this is y equals mx plus c. So the first thing we want to find is the slope. So the slope is change in y over change in x, y2 minus y1, so don't forget minus the negative, over change in x, x2 minus x1. So you get 12 over 6, which is 2. Plug that into the slope, y equals mx plus c. Then to find the c, we need to use one of the points. It doesn't matter which one. I use the 0, -3, because zeros are easy to work with. Cancels out this. C is a -3. Don't forget, don't leave your answer as c equals -3. You're finding the equation of the line, not the value of c. So make sure you plug that minus c back into the c position and rewrite your equation of the line. Y equals 2x minus 3 is your answer. A lot of students stop right here. Kind of drives me crazy because it's not what the question is asking for. Moving on, find the equation of a line that is perpendicular to line L and passes through the point 0, 2. So remember, perpendicular means your slope is a negative reciprocal. Here's our slope from the previous line is 2. So that means the negative reciprocal is a -1/2. That is our new slope for our perpendicular line. We still use the y equals mx plus c, but now our m is perpendicular, meaning it's a -1/2. This is where you have to be careful with perpendicular lines when you find the C. A lot of students go back up here and use one of the original coordinates. You can't do that. These are the endpoints of the other line. You need to make sure you have coordinate that is on your perpendicular line. Neither of these 2 points are on the perpendicular line. The perpendicular line goes through the point 0, 2. You need to use that coordinate. So be careful for perpendicular lines that you use a coordinate that is on your line. So the 0, 2 is what we'll use. So that means C is 2. Again, plug it back into the C position and rewrite your equation. Y equals a -1/2 x plus 2. And here we've come to the end of our IGCSE Paper 21 May-June Series 2019. Notice it's an hour and a half long, and I hope this helps you to learn to think through those questions. I hope that you can become more successful in your practice for the IGCSE exam. So thank you for joining me, and hope to see you again next time.